Okay. Hello and good evening, everyone. On behalf of the Indo-Swiss Building Energy Efficiency Project, I would like to welcome you all to this webinar on external movable shading systems, an effective way to save energy and improve thermal comfort in Indian homes. Today, we have with us participants from the Swiss Agency for Development and Cooperation, Bureau of Energy Efficiency, the European Sun Shading Organization, and from the Indian shading industry to share their perspective on external shading in India. As a quick look at the agenda of today's discussion. So the proceedings of the webinar are being recorded, and the link of the webinar will be shared with all the attendees following the webinar. The presentations will be followed by a Q&A session. The audience can also submit their questions or comments or queries during the webinar in the Q&A tab on the bottom of the Zoom page. And all the questions will be taken up during the Q&A session. You can also reach out to us after the webinar on this email address. So now I'd like to invite Ms. Varnika Prakash, Senior Program Officer at the Building Energy Efficiency Project, to give a brief introduction to the BEEP and its work in external shading.
Thanks, Chinar. So I'll just share my screen. Yeah. I hope my screen is visible.
Yeah.
Yeah, okay. So good evening, everyone, and welcome to this webinar hosted by the Indo-Swiss Building Energy Efficiency Project. I'll start with a brief about what we do. So the Indo-Swiss BEEP is a bilateral cooperation program between the Government of India and the Government of Switzerland, and works on the subject of building energy efficiency. The overall goal of the project is to reduce energy consumption in new commercial, public and residential buildings. And our overall structure, we work on four major components. So we broadly classify them into building design, technology, policy, and outreach related efforts. Our work on external movable shading systems comes under the building technology component, where we are looking at the development of market in India on external shading, and as well as monitoring the performance of the products available. For more details about the work that we do under BEEP, please do visit our website, beepindia.org. The link is given here. Now, why under BEEP we have taken up the issue of external shading systems and why we want to promote this technology. That comes from the very fact that window design in urban residential buildings has drastically changed in the recent years, and there is this trend towards highly glazed residential buildings. I mean, the case is same for commercial buildings, but in residential buildings more so. So here the graph that you see, we can see that in various cities from say 40% to 60% is the average the window to wall area ratio when it comes to the living rooms and the bedrooms in modern day apartments, and that is being sold with the intent that you get better views and better daylighting. However, with that also comes excessive heat ingress inside the buildings, which leads to heating up your insides and then in turn consuming more energy to cool it down. So it is this budding trend of excessively large glazed areas. And we see this more in case of high income housing. This study that we had conducted almost 2 years back showcase that there are certain cities that have a higher glazed area. So you can see here in Ahmedabad, it is quite high, in Bangalore, it's quite high. And the trend is more so in high income housing. Now, that was not always the case, because if we see our buildings, our indigenous buildings throughout the country, there are images from Calcutta, Kerala, Jaipur, Delhi, Pondicherry, Ahmedabad. So there were always this trend of having shutters, on top of your glazed windows, etc. And we can all say with great conviction that these buildings were much cooler as compared to our modern day buildings, very comfortable in any climate zone that they were in. And in our um, uh, the path to modernization, these shutters and these kind of windows started disappearing from the 1960s onwards, and post 90s there was a completely different kind of construction boom in the country. There was also a study done by the LBNL laboratory way back in 2009, which said that external shading can really be a key facade solution to reduce the heat ingress in buildings, and it has the potential to reduce solar heat ingress by 80 to 90%. Now, our work, that is BEEP's work on external shading, started in 2015, where we conducted a national level design competition for external shading solutions in the country. This was followed by, various market surveys that we conducted over a period of 2 years to see what are the kinds of products that are available. Then the information collected through these surveys was converted in the form of a manual on external shading systems. Then last year, we conducted a performance monitoring to test the performance of such systems in real life conditions. And now this year, we are going to conduct two activities parallelly. So one is the market development of these products, and the second is to study the policy implications that if EMSyS is used in a majority of our buildings, then what is the impact it can have on the cumulative energy efficiency of the country. So just a snapshot of the design competition that was conducted. We had received over 30 entries, and out of that, we had shortlisted 5 entries in both the residential and commercial categories, which were further, so a prize money was awarded to the winners, and they developed prototypes, and those were tested at the CEPT University, and you can see the results here that we received. So these are the 5 winning entries that you see, and these were all made by Indian designers. So it was very much customized to the Indian requirement. Following that, like I mentioned, we developed a manual post our surveys that we conducted. So this manual consists of, so if I talk about external shading, there are primarily 5 categories that you see here. And this manual essentially covers 3 of them. That's awnings, vertical screens, and shutters. So the format of this manual is that, so one of the assumptions when we started our work was that not many products are available in the country. However, with the market surveys, we realized that there are quite a few products available, and which is why we collected most of the information and sort of put it in this form of a manual. So for each category, the 3 that I mentioned, so there is a general anatomy of the product that we have explained, followed by the different types. This is not an extensive, representation here, but a few of the types of awnings that you can see here, followed by what are the different, working mechanisms and the mounting mechanisms available for that kind of a product, as well as what is the applicability of, these products in different kinds of buildings. Apart from that, there is more information on the material, on the maintenance of these products, etc. So any kind of information needed by an architect or by a developer to take an informed decision on how to use such products in their particular projects, that is available in this manual. Likewise, for vertical screens, again, the anatomy is described and the different types here. The working mechanisms, the applicability, like so for the shutters that are available. Besides that, towards the end of the manual, we also have a comparative analysis on the solar heat gain coefficient of these products, as well as other properties such as wind tolerance, and then cost and lifespan, which sort of is a major driver for anybody to select the product. So this was followed by our performance monitoring activity, which was quite a difficult task given that we did it last year while COVID had hit. So basically here, we're going to talk about it in detail later. What we did was we had rented two exact apartments in Delhi NCR, and one apartment had been mounted with an external shading device. And we had monitored the performance for both the air conditioned and naturally ventilated case to get real time results. So I think that's an overview of what we have been doing under BEEP so far on external shading. So I'll hand it back to Chinar now. Thank you.
Thank you, Ms. Prakash. Share my screen. So thank you for the introduction. And I now request Dr. Anand Shukla, Senior Thematic Advisor, Swiss Agency for Development and Cooperation, to kindly give the welcome address.
Thank you, Ms. Chinar, and thanks indeed for the invitation. I hope I'm audible.
Yes.
People can. Okay, thanks a lot. So I take the pleasure of welcoming all the panel speaker here and all the participants for this important workshop. In the panel, we have, I'm delighted to see Mr. Diddi from Bureau of Energy Efficiency, Ms. Akanksha, Mr. Anders Hall, Mr. Prabhu, Mr. Rishabh Bhatia, Pierre Chovedov, the team leader from the BEEP team, from Swiss team, Prashant, the team leader from the India team, and Ms. Varnika. You look at actually the combination. We have a representation from the government agency, we have an international expert, and the national experts here. It's a true combination, for any international cooperation project. Since I'm from the International Cooperation Agency, SDC, the Swiss Agency for Development and Cooperation, we always enjoy, when we have this kind of setting where we have government agencies, international experts, and the national experts present here. It's not just this particular event, but in every project, every flagship project that we have been supporting, be it the building energy efficiency project, we are discussing it today, or integration of renewables in building. In short, we say BEEP-RE, the low carbon cement, and also the clean air project in India. So every project we try to bring in the international expertise, and with a bit of customization, we try to integrate in the local context, in the national context. Not only this, we also take lessons from the projects at the national level and try to integrate with the national or international expertise there, because we prefer that the local experience is also being transferred to other countries. As we see today, the topic of EMSyS, the external movable shading system, it is not just the topic which is relevant in the Indian context, it is applicable in every country. Every country it is applicable. So at SDC, since we are part of the global program climate change, we always endeavor to organize this kind of workshops. Now, coming to this particular workshop, EMSyS, it is a part of the larger sort of measures on energy efficiency in buildings, whether it is the building design, orientation of the building, the daylight, the natural ventilation, wall or the roof insulation, or the window to wall ratio. many other energy efficiency measures. But we all know that we reap the maximum benefits of when we are able to integrate all these measures at the design stage. We have seen the curve, as we move along the construction. If we are delaying in integrating these measures, we also are losing the benefits of energy efficiency measures here. Whereas in case of EMSyS, uh, there are dual advantages you can see here. It is not just at the design stage you are able to integrate, but it also offers you a big opportunity of retrofit in the existing old building or maybe the recently constructed buildings here. Now, when it comes to the EMSyS, we need to address several challenges. And what comes to my mind here, and especially when we are pushing it by saying an effective way to save energy and improve thermal comfort, there are three things that comes to my mind. And the first is the innovation part. Innovation, if I elaborate a bit on that, what is additional that you're bringing, which is already available in the market? Sort of additionality. You could say it could be innovation in the technology. It could also be, innovation in the policy. Since we have the presence of both international experts here, maybe we discuss about the technology part, and we have the presence of Bureau of Energy Efficiency. We may discuss about the policy part also here. The second point that comes to my mind is the cost benefit analysis. India being a very cost sensitive market, they look at the first thing that they look at is how much is the cost and what benefit we are going to get. So I think these two elements, the innovation part and the cost benefit analysis, are very, very important. And club these, if we club these 2 points, what comes to my mind as third point is the communication. How do we communicate the benefits of external movable shading system to the common people? How do we communicate in easy to understand language so that they understand about the technology and also the benefits that they foresee will come out by integrating this technology? So clearly, the 3 points: innovation, cost benefit analysis, and the communication, I see a clear challenges that we have at forefront. Varnika has presented about the work that has been conducted so far, whether it is the design competition or the performance monitoring in the practical conditions, the market survey, and also the manual that they have brought out. So I think we have the knowledge and the knowledge products available within the B project. And in the current settings of today's event, I look forward to have an engaging discussion with all of you. And I request at the same time to be more active, to provide your inputs and ask questions. So I think that is how I see today's workshop in next 1.5 hours. So with this, I welcome all the participants and the panel speaker once again. Thank you so much.
Thank you very much, Dr. Shukla, for this wonderful address. Next, I would like to invite Mr. Saurabh Didi, Director of Bureau of Energy Efficiency, to speak on the use of external movable shading systems to comply with Eco-Niwas Samhita.
Thank you, Chinar. First of all, very good afternoon, good evening to all of you. Mr. Pierre, Mr. Anand Shukla, Dr. Anand Shukla, Mr. Anders Hall, Prashant, Mr. Prabhu, Mr. Rishabh Bhatia, Varnika, and my colleague Akanksha, and all other participants. I'm not going to present because my colleague will present on this, but just to highlight here that external movable shading is actually important for us, because if we look at the heat load coming to our buildings are primarily because of the walls or because of the windows we are having. Now, most of us are having uh, curtains inside, but once heat is in the building, then they are heating the room and our air conditioning load is increasing. Now, if we have to plan for 2070 when we are going for net zero, or if we have to plan for uh, carbon neutral India, then we need to look into one aspect, that is cooling, that how we can actually minimize this cooling or requirement of cooling. Now, if we want to save energy due to HVAC, there are two options. One is that we can have very efficient air conditioners, but at the same time, we are having very inefficient building design and they are running all the time. But if we can have building in such a way that their running time will be reduced, or I will say that even if you need 1.5 ton air conditioner in normal circumstances, but if we have designed in such a way, then your air conditioner requirement comes down to 0.5 or 0.75 TR, then automatically we are reducing requirement of air conditioning, running time, but also we are actually reducing requirement of refrigerants, which is also one of the major GHG pollutant. So, so we have to look into all these aspects, and one best way is that EMSyS, that external movable shadings. Now, if we look at the external movable shading, then how, as Dr. Shukla also said, that one thing is that our country is very cost conscious. So as manufacturers or the developers of EMSyS is also there. Now, my request is that how we can make them more efficient and also make them more cost effective. That cost of these things are very minimal. And also we have to look into one more aspect, that our external environment, that due to dust, due to all other pollutants, life of this shading system is actually get deteriorated. So how we can resolve those things? So we looking forward to discuss on all these aspects so that we can have a thing where, or in a future where we see every home or every building is having external movable shading. So that's kind of future I see, but that is linked with the cost and effectiveness of the system. So now I hand over mic to my colleague Akanksha, who will actually present on the perspective that how B is looking for the external movable shading. Akanksha, over to you. Thank you.
Thank you. Good evening, everybody. I hope my screen is visible.
Yes,
Akanksha,
yes, now it is.
Thank you. So I'll just briefly talk about the use of external movable shading systems to comply with Eco-Niwas Sanhita. So the Bureau of Energy Efficiency has adopted a multi-pronged approach to conserve energy in the building sector. And to do this, we have launched the Energy Conservation Building Code ECBC for commercial buildings in 2007 and the revised version in 2017. There's also the star rating system for various types of commercial buildings and star rating for appliances. So that covers fans, lighting, air conditions, etc. And now we is actively pushing for energy efficiency in the new housing sector through the launch of Eco-Niwas Sanhita Part 1, which was launched in 2018, and Eco-Niwas Sanhita Part 2, which was launched last year. The building envelope solution set was also launched for ENS last year. There is also the handbook and online tool for applicable designs of energy efficient residential buildings. The Building Materials Directory of India, an online tool where materials even such as external movable shading systems are available for everybody to look at and to use. There's also Nirman Awards, Energy Efficiency Label for residential buildings, and the National Training Program for ENS and ECBC. Talking about Equiniva Sahita, it's the Energy Conservation Building Code for Residential Buildings, which was launched by the Ministry of Power on 14 December 2018. And part 2 of Equiniva Sahita, which covers electromechanical and renewable energy systems, was launched on 16 July 2021. ENS 2018 is primarily for the building envelope, which covers roof, walls, windows, and outside openings of residential buildings. And it sets the minimum performance standards to limit heat gains for cooling dominated climates and to limit heat loss for heating dominated climates. It also ensures adequate natural ventilation and ensures adequate daylighting potential. I'll also briefly mention the provisions of ENS 2018 for natural ventilation. It defines the minimum openable window to floor area ratio with respect to the climate zone. To define daylight, there is minimum VLT with respect to the window wall ratio, and heat gain and heat loss through roof is defined by maximum U value for all climatic zones, and envelope excluding roof is defined by maximum residential envelope transmittance value, which is RETV, for all climate zones except cold climate, and maximum U value for cold climate. To define RETV, it's the net heat gain rate through the building envelope of dwelling units divided by the total building envelope area, so excluding the roof. So the provision of RETV in Equiniva Sahita defines it to be less than or equal to 15 watts per meter square for composite, hot and dry, warm and humid, and temperate climates. With the trend of increasing area of glazings in urban residential buildings, the use of EMSyS will enable to go for a higher window to wall ratio if EMSyS is implemented in these buildings, and more glass usage is possible, which will reduce the effective SAGC for the building's envelope. So as ENS gets adopted, external shading will gain even more relevance, and for buildings to comply to these standards specified in the code without compromising on WWR, it will become necessary to use systems such as EMSyS, and we is planning to conduct more workshops with EMSyS manufacturers and other building industry stakeholders to promote its development. So this is what we're doing right now to promote EMSyS, and we're looking forward to more inputs from you, and happy to take any questions. Thank you.
Thank you very much, Mr. Didi and Ms. Krishnan, for this very informative presentation. Just share. So now moving forward, I invite Mr. Pierre Javoydov, head of the Swiss team at WEEP, to talk about the significance of external movable shadings in the energy balance of a building. Mr. Javoydov.
Yeah, thank you. Is my presentation visible?
Yes.
Okay, so good afternoon, everybody. Welcome to this this workshop, this webinar. So I'm going to talk a little bit more specifically about, let's say, the link that has been mentioned before also between technical quality of air conditioner and of the shading, and a little bit look at how it goes together. So first, I will do a very brief historical refresher. It was already done, but just to show a few examples. Then external movable shading, why does it come? Because some reasons for the reintroduction maybe are that it did exist, as mentioned before, but in India it has been lost somehow because of an era of modernism or something, where also ASHRAE has to do something behind it, because in US people are not using external shading. Then there is also this lack of manufacturing in India, and that one need to have fabrication in India, DESHI technology and cost can be reduced then. Then, as mentioned, it's not an innovation. The innovation lies in the technology, but not the principle. A lot of buildings in India had external shading in the past. And then the added value of shading is that it does not compete, but complement other technologies like active cooling. So I'll describe an illustrative case study, and then the history and market development in Europe will be covered by my colleague Anders Hall after me. So now if we look at the passive measures, because some years ago, residential were considered as a kind of building with no envelope, but with appliances, essentially. In between, the things have changes. If you look at, for instance, International Energy Agency, Future Building Forum think tank, it gave clearly a message say that there is an urgent need to rethink about the approach toward passive design thermal comfort. So this is something which came in IEA, even though the IEA was not so much prone to this. Then there is also the LEED labeling, which is the well-known LEED labeling, and it has also relatively recently started talking more about solar shades like stationary awnings, drop arm, or external solar shades. Then we have in Switzerland, which has been a pioneer, some kind of presentation about the importance of internal blinds as compared to external blind. That means the external blinds are about 5 times better than internal blinds. And so just to explain the principle in the simple terms, I think if you have a glazing, whether it's a single or double, if the sun is hitting the glazing and then it's hitting, then you will lower the blind. But a good part of the solar will go through the window and will be captured as a solar collector by the screen or the lamella blind inside. And only a small part of it will be reflected. So which say that globally, by exchanging the heat that it's gaining into the house, it's directly heating the house inside. And then we see that the solar heat gain coefficient, which is the ratio between the solar radiation heating the window and how much is going through of it, which is in this type of system at least 50%. Now, if you go to an external movable blinds, so you have the sun trying to hit the window, but actually it's only a part of it. A lot of it is reflected by the movable blind, and only a small part is going inside. So which means it's quite relatively easy with external shading, screens, etc., to have solar heat gain coefficient in the tune of lower value at 15%, easily 20 and 15 and even lower. So now if you look at some of the internal build or typical building in India, Calcutta, the French Quarter, Jaipur Old Town, or in New York, in US in the 1920s, a lot of the buildings, hostel, they did have this kind of shading. We can see some shading in some part of India sometimes. It's quite rare external shading. And now what we see is typical in Gurugram, not Gurgaon. This is the old wording, sorry. You can see people having curtain inside, all closed down, and you can see the AC compressor outside, and people try to keep the heat out. So they close the curtain the whole day, hoping not to get too much heat. An interesting thing is in Rajkot, where we could see that in some area, very specific area, it looks like it's word of mouth or something, where people have kind of ad hoc external shading, and it's the one who started has helped the other to do the same. So we could see the same thing. Now, one thing, why is Switzerland in a sense legitimate to talk about external shading in terms of a little bit more sophisticated than shutters? Already in the 50s, this lamella blinds were already sold in Switzerland, but you can say the first real study of the performance And actually in laboratory measurements by the Swiss Federal Institute for Material Testing happened in 1979 already. And you could see that lamella blind of 80 millimeter and closed or with 40%, 45% could reach as low as 0.13 SHGC value. Then later, there was also some more calculation simulation. I'll come back to it later. So one important study, which was already mentioned, I think, is the famous Lawrence Berkeley laboratory in US. They really also took care of testing external shading, external lamella blind, essentially, and they showed that, saying that average daytime cooling loss due to window could be reduced by 78 to 94%. It's really high values, and compared to conventional interior shading, sorry. So actually we can see here that even in US, where people don't use it, actually the famous Lawrence Berkeley laboratory, they already have done more than almost 15 years ago now, serious study demonstrating that. So in Switzerland, if you see, very often people, you can see half of the building at least are equipped with that, even more. Some have roller blinds, or some have kind of fancy shutters. Some also are using the same kind as in Rajkot, in a sense. They use kind of curtain, and some different thing like fancy shutters designed by architect or so. So you can see a row of different systems which are available. Of course, I would say the most common is this lamella blind nowadays, because they are controllable, and even some of them have up to 2 or 3 different possibility of orientation depending on the lower, middle, or higher part of the blind. So you can keep it partly open on top to get better daylight, but then cut the solar gain completely on the rest. Another thing which is also very important is that in India, people have the impression that we have a lot of direct solar radiation, which is true. But if you took the Delhi data in summer, in hot summer, you have more than 50% of diffuse radiation, which means that for direct radiation, the conventional kind of static shading does the job somehow, but not when you have more than half of the solar radiation coming in a diffuse mode, because it comes in all directions. So it's very difficult then to do an efficient solar protection with a low solar heat gain coefficient in this kind of context. And it is when it is the highest temperature that in Delhi you get the highest amount of diffuse radiation. And this is based on data which were collected by the Solar Energy Center near New Delhi. And I think so these are really data which are, you can say, reliable, done by the MNRE. So we can say that in modern buildings, so to say, envelope is often the main source of heat gain loss, especially in residential. So if you look now in the window to wall ratio, only without talking of shading, if you look at the building which has 10% of window to wall ratio, or if you look at the same building having 40%, you can see that you almost double the cooling load. So the window to wall ratio is one way to reduce the heat loads, but for some reason of some fashion or architectural fashion, people have a tendency, or builders think that there should be a lot of glazing, even though it's not always needed in terms of even daylighting. So now what we have done is to do an example of a west-oriented bedroom, about 13 square meter. The window to wall ratio is about 40%, a single glass. We have taken 9-inch brick wall, and there is a room AC. And we are looking at 2 main strategies: passive external movable system, which is EMSyS, and then active means with a better rated AC. So what we have taken is, can you see my cursor?
Yes,
Yes, we can.
Yeah,
Yes,
okay.
we can. Yes.
So if we take, I have taken the one rating plant which applied to light commercial, but I think it's to show the progress now. If we take a 1 star, we have, let's say, something between 2.7 and 3.1. If you take a 5 star, you have at least 4. So we have taken 5 to say this is the schedule 24, and I think this is a good example. So now if we look at the heat flux into this room, and I have drawn the diagram, the flux diagram, the energy flux diagram, Sankey diagram at real scale in relative terms. So now if we look at, if we have no shading and a 1 star AC, you see that the most of the heat loads come from the solar gain. The envelope gain is only a part of it. It's only, you can say, 70, 80% of the heat coming in the building, in the room, is met by the solar heat gains. Now, if you look at now the heat rejection, that means what is going out from the compressor and the air cooler, then the electrical consumption for the cooling, to remove this cooling load, the AC is 1100 in this case. Now, if you switch to the 5 star, then what happened? You still have the same solar heat gain, the same envelope gain, but then you are reducing your electrical consumption by about 42%, right? Without adding shading. Now, if you take again the same, the basic 1 star system, and then if you go to a reduction, keeping the solar, having only an external movable shading, but keeping the original 1 star, you see that you are already reducing from 1100 to less than 700. So reduce electrical consumption, keeping the same AC with the shading by 40% almost. Now, if you combine the two, if you add the external movable shading and a new 5 star AC, then you are reducing the total from 1100 down to less than 400, so about 64%. So if we make a summary of it, if you look at the cooling load that you have in kilowatt hour per square meter and per year of floor area, you see that you go down from about 240 to 148. I forgot to say we have taken 24 degree as the set point for the simulation. And then if you say we have in India, seasonal energy ratio of 2.9, this is 1 star, and say we are at 5 with much better one of which are possibly available today, then you can see that the blue being the SHGC value here, SHGC of 0.85 single glass, and then the SHGC of an external movable blind. Then you can see that we are getting this reduction from 83 to 51 square kilowatt hour per square meter and per year in terms of electricity consumption. Now, by going down from the 1 star system down to a 5 star system, we are getting a good reduction from 83 to 84. But if we combine the two, having an SHGC of 0.17, we can go down from 83 without shading with a 1 star AC down to 30 when you have the external shading plus the 5 star. And I'm not talking of the question of cost in this case, even though Anand mentioned it, it's very important, but nevertheless, the idea is to explain the difference you can get. Of course, this is an illustration. It doesn't mean you get this in all buildings, depending on the window to wall ratio, depending on the orientation, depending on the local climate. Of course, this may vary, but the trend is really the one which will be also shown by my colleague Prashant in the next presentation. So one thing when people talk about ECPC air, that means the Econivas Samhita, if we take the simple equation of applied only on one room, just this one, and saying we would be on the green, for a green building, now people are recommending to have 12 watt per square meter, not per Kelvin. Sorry, there is a mistake here. And if you have a window to wall ratio, that could vary from 12 to 45%. So here on the vertical axis, we have the window to wall ratio. And on the horizontal axis, we have the solar heat gain effective that you would introduce in the formula in the equation of the Econivas Samhita code. Now, if you say this line has been calculated so that we have a constant renewable residential and thermal transmittance of 12 watt per square meter. So this is a constant, but what vary is the solar heat gain coefficient. It goes decreasing, and the window to wall ratio going increasing. So now if you say with the glazing with color not too much, it's possible to go down to 0.27 maybe. Now if you go up and would like to go lower, then you enter in the domain of external shading, which can really help you. Having with external movable shading, you will be much lower than this. So that means you could go to much higher window to wall ratio and at the same time be compliant with RETV. Of course, this is not, the shading alone is not sufficient. It's very important to realize that if you have a concrete wall that will let you enter a lot of heat, then it would not be sufficient just to put the external movable shading and or especially anti-solar glazing. But this show you that this somehow give a compromise. That means if you would normally be in many places, you can say in affordable housing, you are in this range. So there you don't need, because with a single glass, you are there. So you say if you have something like 12-15% window to wall ratio, you don't need really the shading. It will improve your comfort, but you don't really need it. If you want to go much lower, you could use it also, and it would improve your comfort, thermal comfort. But then when you go to a little bit more higher income kind of new project, you can see that you are soon reaching a level where glazing cannot compete anymore and static shading cannot compete anymore. So external movable shading allow you to have a little bit more external shading, a higher window to wall ratio. So that means with a window to wall ratio of 0.2, the SHGC should be down to 45%. But if you have a window to wall ratio of 40%, then you should go down at 0.7. So now I think what is also important once you have understood the principle is that you should be able to use software. And we know in India that people like to use free software. So I just give here 3 examples. One is if you are using Energy Plus directly, there was a very serious validation exercise between experiment and simulation. You can see here in 2011 done by some people from the Swiss Federal Institute for Material Testing and some other colleagues from Germany, Scotland, and USA as well. So which means since 2007, you can say simulation can be done quite accurately for external shading. Now there is one software which is free, which is actually using Energy Plus, but it has a much easier interface. It's mostly designed for commercial buildings, but it works well also for residential in a sense if you design it so. And it was actually presented 1 year before by Professor Selkovitz from LBNL, Lawrence Berkeley Laboratory, as a new tool for it. There is also an Indian version which has been developed by CEPT in Ahmedabad, which is Comfen India for awnings. It is especially designed for awnings, but you can also use it then after for external movable blind like fabric and it has been still developed. That means in 21 there was the new version 5.0. If you just type Confen, you can go and download it. Then there is another software which has appeared relatively recently, which is an early design software, ESBO Lite, which is endorsed by the European Solar Shading Organization, which is also a freeware. And I think so it gives you an idea of the different kind of tools which are available. Some other software can also, but not all. Typically, old software like eQuest are not able to deal with external shading. That you should know for the one who are using eQuest. So in conclusion of this short presentation, I would say external shading, it's an important element for the reduction of solar gain, especially when the window to wall ratio has a tendency to be increased. It can help in reducing somewhat the RTV value or keeping it low by playing on the solar heat gain coefficient effective. Then this simple software, they are not all simple, but let's say simple software should be available for green consultants. So I have shown you the one which is here, ESBO most likely, and ComFan they are not simple software in a sense, but they are able to be used it's not too difficult to use them. And then I think one of the proposition I would push is to integrate an annex about EMSyS in Econivas Samhita, which could help people to calculate the RTV value with a kind of recognize the data value. And actually another thing which I would recommend is that EMSyS should be part of the architectural curricula, because I don't think it is teach my, it's mostly always still the static shading which is taught. And I think it should be improved in terms of teaching. So thank you for your attention.
Thank you very much, Mr. Jabaidov, for this very interesting presentation on the external shading. So now I request Mr. Anders Hall, President of the European Sun Shading Organization Academy, to share with us the international experience and market development of external movable shading systems.
Okay, so first question, you hear me okay?
Yes, very okay.
And let me know if you can see my screen properly.
Yes, yes, we can see your screen.
Okay. So first of all, it's my first appearance in the scope of this exciting project between Switzerland and India. So I'm very excited to be here today. So thank you for the organizers to open up this opportunity for me. I'm talking you today as, okay, start my video. Sorry, is that okay?
Yes.
You got my...
Yes, yes, we can see your video. Thank you.
Okay, thank you. Thank you. So I talked to you today predominantly in I have two hats in my professional life. And the bigger hat today is that I've been active in the European Solar Shading Organization since 2006. And for the past 2 years, I'm the acting president of the organization. So it's out of that scope that I will share some European experiences with you today. But I also have a private life and I'm active in the shading industry. As of last week, I launched my own private consultancy called Shade Academy, which is partly trying to solve what we just heard our previous speaker mentioning about the curriculum for architects, etc. I created an online platform for training architects that we can discuss maybe at another occasion. Anyway, so this is my slogan since several years, because the best kilowatt hour is the one we don't need is absolutely about the proper and intelligent use of solar shading. There are so many aspects around these issues, and we see the International Energy Agency reports coming. We see India here standing out significantly. We think that the European Union look like we are the best in the class, but I mean, it's still about a doubling of energy just for air conditioning the next couple of years. And without going into any kind of politics, a lot of European countries are very dependent on import of gas and oil to keep warm in winter and cool in summer. And we know with the present circumstances that this becomes a great issue. So there are many aspects around these things. But what's important to me here is that Faith Birrell, the executive director, here in his conclusions, he says that energy efficiency should become the first fuel. And of course, that could be many different ways to approach it, but definitely solar shading and what we're discussing here today is absolutely one of the options towards that. And these are numbers I could actually read in a Swedish magazine just a couple of weeks ago. An extraction from this report, Cooling India, about the increased use of air conditioners. A big topic here in Europe, and I will show you. But I mean, going from domestic 50 million air conditioners in India estimated to become 1 billion units in 2050 will have a significant impact on your energy consumption to stay cool, and in some cases even to stay alive. And when I say stay alive, you are now talking to a guy. I'm located right now in Gothenburg in Sweden, up in the north, not far from the polar circle, but just south of me in Holland. In 2018, during the heat wave, we saw the numbers that about 700 people more than normal died because of overheating. So, and it's becoming an increasing problem. So don't think that we live in a very cold environment here in Scandinavia. We are getting very warm here as well, sometimes nowadays. During my visits the past years in India, because in my previous job as working with international business development, I had the opportunity to come to India quite frequently. I made a good friend, Adil, at the Global Evolutionary Energy Design. And I don't know, Adil, you might be one of the participants even today, but I'm using this slide because when we talk about energy, energy consumption, production, etc., it's about megawatts and terawatts, etc. But the human mind has a difficulty in grasping. I mean, it's like saying, how long is a string? So he gave me a wonderful comparison here. So the calculation he made states that 1 square meter of a glassed facade in New Delhi during 1 year is exposed to the same amount of energy that you need to make 40,000 cups of coffee or boiling 30,000 eggs for breakfast. And I think this is a wonderful way of describing how much energy we are potentially talking about. And the funny thing is, or the strange thing is, that we nowadays in modern buildings very often use mechanical appliances to remove that energy back out again for us to be able to survive or live or be productive at work. As I said, I had the opportunity to visit India, and I came into different kinds of events, seminars, discussions, panel debates, etc. A very interesting learning experience for me. But I also realized something very quickly, and that was, it's one thing to share, like I do today, about knowledge from Europe, but it has to be made in India for India. That's really key. So back in 2006, I managed to initiate a study project together with Terry. And you see some pictures here from the group. And when we started, they built these small buildings in a park in New Delhi, where actual live measurements were made They were looking then at the daylight in the room, the thermal comfort factors, the visual comfort, and the energy consumption. Started off with interior roller blinds, and that's done in the total scope of this study. But we also decided to add on the external solar shading. And due to COVID, we had a couple of year delay now, but as we speak right now, they are concluding the measurements for the external shading. So quite soon we will have the final report. So there was a base case with no blinds and then 3 different versions of each application that was measured, tested, and recorded. And I don't want to run too much ahead, but I just took one snapshot out of this, the report, the preliminary report last night. And we see here reduction in peak loads on quite significant levels with compared to no shading. We talk about 30 to 40% potentially. But the external results will be added to the report. So I think we could leave this initiative at this point and instead say it would be very much of interest to me to have the opportunity to come back at a later date where we can do a proper and separate presentation of the full report. So the reason for sharing that with you, though, is that we in ESO, the European Shading Organization, back in 2019, decided that we need an unbiased, as far as possible, unbiased documentation on what our solutions could mean for Europe and the European building stock in terms of energy, temperature management, carbon dioxide, etc. So with the help to finance it from the industry, because it wasn't for free, we signed a contract with this consultancy firm in Germany called Guidehouse. They are recognized all the way up to the EU Commission. They do consultancy work for the insulation industry, for the glass industry, for the facade industry, etc. And now it was time for them to do their first study on our behalf. And we defined the criteria. We had to make some limitations here. So we said it's all building stock in the EU, including UK. Even if they recently left, we still had the stats. And for us, it was important to have UK still there. So it's both about domestic and commercial buildings. We limited ourselves to external shading initially. And we said there are 2 scenarios. BAU, we call business as usual, which means that the EU Commission, the building regulations, does not give us any additional recognition whatsoever. The preferred scenario, number 2 here, they calculated with a very conservative increase in volume, but also moving away from manual towards automation. Because this is a very, very strong key success factor if you want to reach the real numbers, the real potential numbers. Of course, manual shading is better than no shading at all, no question about that. But if you automate it so it really works every time it's actually required, you will reach even further. It was calculated combined with the use of air conditioning. Exactly what we heard our previous speakers today discuss. And they were using the EU models for climate evolution, the climate change, and the decarbonization of energy production. So that's part of the whole thing. So now I will give you a brief summary of the 4 main outcomes here, and they are quite remarkable. You see 2 lines here. The red line from 2020 to 50 is that bow scenario. We don't give our industry any recognition whatsoever. We keep on going as we're doing today. We don't change anything. We see how the share of building, the number of buildings in need of new air conditioning will increase. The green one is then that preferred scenario. And the conclusion here is, by Guidehouse, is that dynamic solar shading can stop the increase of additional mounting of an installation of air conditioners in the future in Europe. That's quite remarkable. The next one is about final energy in terawatt hours per year. So again, the red one, we do nothing, we stay the same, business as usual. But the green one shows what will happen with the final energy if we do reach the preferred scenario with these external shadings. And you see already in 2030, there will be a significant saving. And by 2050, when the penetration of this has reached further, it's quite remarkable again. And you can also see here, they comment that the improved COP of the air conditioners is part of the calculation, right? Next one is about a reduction of greenhouse gas, CO2. So here we see the red curve making a dive, and that's obviously because we are turning towards renewable energy production here, more wind power, etc., less coal. But still, with the preferred scenario, we will be able to cut that in half potentially by 2050. And the last one. This one is a little bit complicated, so I will take you through it. I will talk you through this slide step by step. We start looking on the left side of the slide where it says added cost and avoided cost. So it's about the mindset here now. So if we go above the dotted line, we need to spend some money. If we go below the dotted line, we will save money in this calculation on CAPEX and OPEX. So obviously, we need to increase our use of shading, which means we need to invest some money. But we saw in the previous results that will mean that we will save on capital investment on air conditioners. And as a consequence of that, we will then save on the running cost of that air conditioning in terms of energy and maintenance, etc. And this ends up at, in 2050, not until 2050, but in 2050 as 1 year, a total saving on 14.6 billion euros per year. It's a massive amount of money. And when I saw this, I started thinking that who will actually be gaining this money? And I realized we are talking about final energy, which means people like you and me, who receives the energy bill every month from the energy supplier. So it's people like us. So it means owners, developers, and tenants, building owners. We will save that money in Europe. And as a consequence of that, society will save, because it means that our requirement for electricity will go down or stay low. And of course, there is a third step as well, which means that our planet will obviously also gain from this in the end. Now, these results have gained recognition all the way up. I just give you one example, because I hear how you talk now about implementing some additional regulation in the building code in India, etc. The same thing is going on in Europe as well. And the Climate Change Committee in the UK, which are not far from the government, you could say, are recognizing dynamic solar shading to be a passive solution. And Lord Krebs, who's chairing this committee, he says that shading, well, in Europe at least, they say it's not costly, but he means not costly compared to other things that might be required. The problem is that we just don't do it. So you see, we need also in Europe to continue to work on the awareness of using solar shading, even if we have countries like Switzerland and Norway and Germany, where the use of shading is quite broad, but we still have white spots on the map here in Europe as well. And here is actually, I used my own mobile and we made a solar shading installation in a private villa. It's a friend of mine, just to show you one example of how it could look. Oh, sorry. I wasn't sure whether there is some music, if that disturbs you right now, or. We can stop it there. I just wanted to show you, because when you see these pictures, like the private villa in the upper left corner here, people not knowing and understanding about the shading fabrics, they say, oh, it looks terrible. You are shutting down your home. No, you're not. With external shading, if you stay with darker colors of the fabric, and a certain level of openness factor in the weave, you have absolutely a surprisingly good view to the outside, even combined with good energy efficiency performance. And you see here as well, we use awnings, a lot of awnings on our houses in Scandinavia. And the apartment blocks, the one on the right there, the pink colored one, on the lower levels, you can see the beige colored external screens. They are really, by the architect, really nicely integrated in the facade. It's from a building block in Oslo in Norway 2 years ago. So just to give you a visual that we are doing these things. In my seminars, I very often would like to talk about the challenges and potential solutions. And I have limited time today, so I will just cherry pick a few. Here is one challenge, and that is simulation softwares. This building in London was renovated back in 2016, and they were simulating it and advised that even without a solar heat gain coefficient given from the glass, they said these apartments on the west facade will never reach above 27 degrees, so you will be all fine. Well, it turned out to be 47.5. So the water evaporated from the water locks in the shower and the toilet and the kitchen, so it smelled of the sewers, from the sewers in London, and the developer couldn't sell the apartments. This is a problem. Be aware that a lot of the simulation softwares around in the world today are mainly developed in the beginning to simulate HVAC and not glass and shading. We heard previously about Energy Plus and Confem, etc. Thumbs up for that. And again, I would like to give you a reminder about ESPO. And you have a download link here where you can download it for free. And the company developing this, well, it's not that new. ESPO saw daylight in 2012, roughly. And it's a Swedish company. And I will record some training movies starting after Easter holiday together with EQUA in Stockholm that will be put online for you, for your benefit. So we can come back to that. We mentioned the curriculum of training of engineers and architects. And this is another challenge I've met. I say that from 2015, I had seminars on different events around the world, meeting roughly between 300 to 600 architects and consultants per year. And this was the same story everywhere, that we have never done this. I mean, we are uncomfortable dealing with solar shading because we have no experience, or at university, nobody trained us on these things. So we don't know how to care now when we know that we have to care. And the worst one is really old-fashioned building regulation, where they say, we know we should do something, but we don't need to for compliance, so we don't spend time on it. And we just get compliance. This happens to be a building at Victoria Station in London. It could be in New Delhi, in Mumbai, in Singapore, in New York. It looks in Gothenburg, in my own hometown. And when I see these buildings looking like this, it's like laundry in the garden here, right? I see facade design for compliance. I see lack of knowledge or interest, lack of budget, or I just see we leave the problem to the tenant that move in later on. And I can tell you, the architects I interview, what is their impression about the building that they spent a lot of heart and soul to design, and then it starts looking like this later on. In most cases, they just hate it, and there is nothing they can do about it. But the solution here is partly, I mean, just ask us. I mean, we have some of the best technical documentation that we can share with you free of charge. And we are working on we offer seminars and all kinds of things at the European Solar Shading Organization. We became very active on LinkedIn about a year ago. We are continuously very active here. And recently we just opened a YouTube channel as well, with the ambition to build up more content over time. And as I mentioned, my private initiative that I launched just within the last couple of weeks, the online platform I call Shade Academy, where I target the training for consultants and specifiers. There is about 11 hours in total of material recorded by now, and it's going to grow and over time. And before I leave you, a last slide. Another personal conclusion from all my years. I started with shading back in 1997, and I'm still here. It's not about waiting for Elon Musk to come up with the solution here. We have the solutions it's in front of us, but we need to start cooperating. Because cooperation is working together, not working at the same time. And that goes for intellectual exchange, but it also goes for how we budget what we do. So in the return on investment for external solar shading to your next building project, you need to start looking also at the cost of people in the building as part of the budget. And you've seen the less HVAC installation, etc. These are not budgeted correctly, as I see it today. So by this, I thank you for your attention, and I hope you have a continued good meeting.
Thank you very much, Mr. Holz, for this very enlightening presentation, sharing the experience in Europe and the relevance of external shading. So next we have Mr. Prashant Bhagre, Senior Program Officer at BEAC, who will be talking about quantifying the impact of external movable shading in a residential apartment.
Hello, everyone, and let me start sharing my screen. Yeah, is my screen visible?
Yes, it's visible.
Okay, so I think we already have a lot good kind of context set for external movable shading system. We heard from B what India is doing and what are the things are there. And then we also heard international perspective and also some history and the products and the work which is being done under Indo-Swiss Building Energy Efficiency Project. So what I will cover is the specific piece of work under BEEP. Under BEEP, we have quantified the impact of external movable building under real life scenario. So let me start. Okay, so my presentation will cover what was the objective of this monitoring study. And since it is not a kind of thing, we need to develop the methodology, how we will be doing this study. And later I will come to the results of this. About what kind of temperature conditions we are getting with them, what kind of cooling saving. What was to assess the real life impact of EMSyS product on thermal performance of selected room under two scenarios. So the first one was under naturally ventilated mode, where we tried to measure the impact of EMSyS when the building is not air conditioned, it is running at naturally ventilated mode, and we saw the impact on the internal temperatures. And the second thing which we did, we run the air conditioning throughout the monitoring period. We saw how much cooling is required and without EMSyS. So
sorry to interrupt you a bit, Prashant, but I think the connection is not very strong. So maybe if you could switch off your video, maybe we'll have a better voice and presentation.
Okay, sure.
Thank you.
Let me stop my video. Okay, is it better now?
Yes.
Okay.
Thank you.
So okay, so apart from kind of doing the real life monitoring, another objective was to develop a comparative energy simulation model and try to predict the performance under different conditions. Like we can do a real life experiment for a limited period or limited location, but through simulation we can estimate multiple scenarios and multiple locations. So that is what also was the objective. To begin with, we started looking for where do we do the monitoring and what should be the criteria for that. So we started looking for two kind of identical spaces which will have same layout, same orientation, and they will also receive same solar radiation. And we also wanted that the impact of mutual shading and all is minimal or it's not there, and the installation is easy, and then the space is available for monitoring for a long duration. So this is the location which we have found. It's in sector 104 in Gurugram. And here is the image of the building. And then what we have done, we have rented two flats, exactly one above other. So these two flats were located in 10th and 11th floors, and one room in each of these flats were selected for the monitoring. This is the plan for the typical flat. It's a 3 BHK plus a servant kind of flat, about 2,500 square feet of area. And we selected one room, which is highlighted in red for the monitoring purpose. And it has a west facing window, and it also has a balcony. So it's a kind of a real life situation where you may have more glass, but it may also have some kind of fixed shading, you can say. So this is what was selected for the monitoring space. And then these are the images of experimental setup. So as I said, the objective was to compare the impact of EMSyS. So the first case was the business as usual case, or you can say the one room what equipped with normal internal curtain, which we normally have in our houses. And the second room was equipped with external movable shading system. This is image from inside, and this is the image from outside, and this is the product is looks like this zoomed in image. And what we did is we tried to calculate the effective SHGC. You have limited tools to do that, and one of such tool is that LBNL's Windows software. And by using that, we found that the effective SHGC with this kind of shading and single clear glass, we get an effective SHGC of about 24%. The cost numbers are also mentioned here. So this was the experimental setup, and then we wanted to look at what are the key parameters which we want to monitor during the during the monitoring. So as I mentioned earlier, we wanted to do the monitoring in naturally ventilated mode and air conditioned mode. So in naturally ventilated mode, these are the raw data which we measured, or we did the continuous logging of this data. So air temperature, globe temperature, which is used to calculate the, which is based on the inside surface temperatures, and the air velocity. So these were the set of raw data which we continuously monitored during the monitoring period. And then there is some calculation involved to get the results from these raw data. The equations and formulas are given. I'm not going into those details. And we have taken this from reference, which is shown here. And the key thing, what we wanted to calculate from these raw data is the operative temperature. So operative temperature in simple terms is the temperature what you feel effectively. So it is the resultant of air temperature which is there inside, and the surface temperature which is around you, and also the air velocity which is moving over your body. So a combination of these three parameters gives you the operative temperature. And we measured the performance of EMSyS with respect to operative temperature. So that, which means we calculated operative temperature with internal curtain and operative temperature with EMSyS in naturally ventilated mode. The next thing was to do the monitoring in air conditioning mode. So in air conditioning mode, we had these sets of parameters which we measured as raw data. So room air and relative humidity were the two parameters, and these three parameters were measured at the outlet of indoor unit of air conditioner. So air temperature, relative humidity, and flow rate at the exit of indoor unit of air conditioner. And then again, the basic formulas were used to calculate, to do the calculation, perform the calculation, LP values from temperature, RH numbers, and calculating mass flow, and then the heat load. And this was the output parameter which we used to compare the results. So actual thermal cooling demand. This means the amount, this is the amount of heat which needs to be removed from the space to get the desired temperature. So this is what we compared as an output parameter. In addition, we also monitored solar radiation, total direct diffuse, ambient temperature and RH, and inside surface temperature. It is also used to validate and prepare the simulation model and calibrate it. These are the set of instruments which we have used during the monitoring. So on the top you see it is used in both naturally ventilated mode, the probe to measure relative humidity and temperature. This is for velocity, for surface temperature, and for globe temperature, for solar radiation. And then we use multiple loggers to measure temperature and humidity in multiple places also. So this is these sets of instruments are used in both modes, naturally ventilated and air conditioned mode. While in air conditioning mode, we wanted additional measurements to be done at the indoor unit of air conditioner. So we use the balometer. This is how it looks like, and we can measure flow rate, temperature, and humidity at the exit of indoor unit of air conditioner. This is how we place the instrument inside the room. So you see the distance from the edges and height of the sensors. They were kept according to the standards which are given. And then here you see the schematic, what all is measured. So one logger connected to multiple sensors, which is measuring globe temperature, air velocity, temperature, and RH and surface temperature also. This sensor will be there in both the rooms. And we will have one of these sensor in one floor to measure the outdoor parameters, solar radiation, and the outside temperature and RH. In air conditioning mode, inside everything is same. Just one addition, which you see in the image, the instrument, the balometer, which is used to measure the airflow rate, temperature, and RH at the exit of indoor unit. Okay, so like this is how we kind of followed the experiments. So naturally ventilated case monitoring was done for about 8 days, 22nd March to 29th March. And before starting the experiment, we did a kind of flushing for 2 days so that both the rooms are almost at same condition when we start our measurements or monitoring. And we also kept a kind of a schedule for opening and closing of sliding doors, EMSyS, and curtains. And so basically the idea was that during the daytime, the EMSyS and curtains remains closed, and during night time, they are open for having the natural ventilation. And this is how we done the monitoring in naturally ventilated case. In air conditioned case, the monitoring was done for about 9 days. Similarly, we did the flushing to have the same initial condition before we start the measurement. All the air conditioner were put at a set point of 24 degrees Celsius. And again, the same principle, we kept the EMSyS closed or curtained down during the daytime and open during the nighttime. So these were the kind of broad overview of the methodology. Let us look at what kind of results which we have got from these experiments. So first, the results for naturally ventilated case. And here we are talking about operative temperature. So operative temperature is the temperature what you feel. So what you see the results in graph. So you will see two results. One with the internal curtains and one with EMSyS. And you have temperature on y-axis, and then you have kind of 1 day interval. And here is the graph for internal operative temperature with curtains. So if you see that the temperatures are peaking up to 30, and sometimes it is going up to 2, and the peak you achieve at around 4 to 5 p.m. kind of time, because it's a west facing window. So the solar radiation or solar ingress will be maximum during the second half of the day, between 3 to 6 p.m. And then that's why you see this peak occurring at around 3 to 5 p.m. So the similar graph with EMSyS looks like this. So it is below all the time as compared to the condition with the internal curtain. And you see that, okay, you get about a temperature difference of peak temperature difference of about 3.5 degrees Celsius during the time. So about 3-4 p.m. you get a difference of difference in inside temperature of about 3.5 degrees Celsius. Next, if we look at the air conditioning case, then we were trying to see how the EMSyS is making impact in terms of cooling requirement or cooling delivered. So this is again shown for each day, day-wise, and then you on the y-axis you have cumulative cooling delivered. So this is the amount. What it means is that this is the amount of heat which needs to be removed from the space to get the desired set point. So for example, if the total amount of heat which needs to be removed is 300 kilowatt hour, and if your air conditioner has a COP of about 3, then you will require about 100 units of electricity to move this much amount of heat from inside to outside. So let us see the results. And here we are showing the cumulative coolings. And during the experiment, we kept the set points as 24 degrees Celsius. So this is the graph which you see for EMSyS. So you see a break here because there was some issue in the measurement and we could not log the data for some time, like which is shown as the blank. So roughly in this 8 days, you see about 350 kilowatt hours of thermal load being removed from the room to the outside. If we look at the similar graph for the room which is having internal curtain, it reaches 500 plus, so about 520 or so. So what we observe that we achieve saving of about 32%. So this will be the almost the same saving in electricity consumptions as well. So in addition to thermal performance, we also checked like how it impacts the EMSyS on the daylight. So what we did is we did some spot measurements in the room, like one which is having internal curtain and for the other which is having EMSyS. And these are the time of the day. So you see the outdoor lux levels are quite good. But what you see, like the room with the internal curtain, these are the inside lux level in 4 points where we measured these lux levels. Of course, in the morning, because the sun is on the other side, the lux levels are low. During evening, you get slightly better lux level, but still, as compared to outside, you get very little inside. If you see the same number for using EMSyS, this is what you get. So even during the daytime, you get good lux level, and during the evening time, you have plenty of daylight inside as well. And at the same time, it is also reducing the amount of heat which you saw in the results for naturally ventilated and air conditioned both. So overall, what you find here is there is a kind of 12 to 14 times lux level with EMSyS as compared to internal curtain. And as a kind of consequence of that, you may not require to switch on artificial lighting with EMSyS, while you may require the artificial light to be switched on with internal curtains. So quickly summarizing the study. So one thing is that during monitoring, even when we kind of drafted the methodology for monitoring, we also had a stakeholder consultation, and we kind of get inputs from the building sector expert on the methodology and the way we are conducting the monitoring. So the study also resulted in developing the methodology in real life scenario for the monitoring. The results which we saw, this is quite specific, like this is for a particular bedroom west facing in Gurugram. In other condition, other location orientation, the numbers may change, but for this particular case, we got a good improvement in thermal comfort in naturally ventilated condition, about 3.5 degree drop in peak temperature, about 32% saving in cumulative energy demand, which means a 32% saving in cooling electricity. And of course, the daylight levels were quite good with EMSyS as compared to internal curtain. As a way forward of this work, we are also doing we have also developed a calibrated simulation model to see that how this EMSyS will perform in other location, other orientation, or other times of the year. So that work is done, and also we are in the process of developing a policy level and under which we are trying to estimate the EMSyS potential at national level in terms of energy saving. So this is the work which is under. So this is what I have to share. If you have any questions and comments, you can write in the chat, or you can ask. Thank you.
Thanks a lot, Mr. Bagre, for this, for sharing the details and the results of the study. And just show. Sorry. So coming to the next part of today's discussion, we have with us Mr. Prabhu MP, Director of FIFER India, and Mr. Rishabh Bhatia, Business Development Manager from the ShadeTech India, to give us a perspective on the market of external shading in India. So now I'd like to invite Mr. Prabhu to give his presentation.
Hi, good evening. I am Gokul, Mr. Prabhu's colleague. So,
Okay.
yeah, he got delayed bit in a meeting, so I will be taking over this presentation.
Okay, sure.
Yeah.
That will be Mr. Gokul.
So I would like to share my screen.
Yes, please. You can go ahead and share your screen.
Yes.
Yeah.
Good evening, all. I hope you can see my screen.
Yes, your screen is visible.
Yeah, thank you. So I am Gokul, General Manager from Pfeiffer India Private Limited. So I'm here to explain about the features of interior and exterior shading fabrics that we have from Pfeiffer. So I will quickly run through this presentation. So Pfeiffer was established in the year 1952 in Alabama, USA. Basically, we are into weaving of aluminum insert screen and also solar control fabrics. So Pfeiffer is around 70 years old company, and we are operating in about 123 countries across the world. So Pfeiffer India is based out of Chennai. Our warehouse, office, everything is located in Chennai. So I just show you a video where we had installed the exterior shading system. So this was installed in Mumbai in one of our customer place along with the motorized system. The fabric what we had used here is Suntex 80 black. This is an exterior grade fabric that comes with a 10 years warranty. The components what we had used here is from Akmada. So this is controlled by motors and with a remote control. I will explain you the features of fabric in the upcoming slides. So just show you the operational and the visibility of our fabrics. It has a good visibility. At the same time, it has a daytime privacy also. So it cuts about 90 to 95% of heat. So these are the few pictures where you can see the first picture shows the daytime privacy. So people from outside cannot see people in inside during the daytime. And it will also cut about 90 to 95% of heat from coming in. And from inside, you will have a good visibility. Like the second image shows the visibility. And the third image is, the first two images are black and dark bronze, the dark colors. And the third image shows the light color, a beige color fabric, just to show the visibility difference. And as always, light color will have more reflection than the dark color. So this chart shows about our fabrics solar optical properties. So we have two range of fabrics for exterior applications. One is Suntex 80 and the other one is Suntex 90. So Suntex 80 cuts about 25% of UV rays, and Suntex 90 it cuts about 10%. So both these fabrics are exterior grade and can be installed externally on the outside of the building. So this will cut about both fabrics in the range of 80 to 90 to 95% heat reduction is possible. So the solar optical properties are mentioned in this slide. So TS is solar transmittance and reflectance, absorptance, and the SGHC values are also mentioned against each color. So as you can see, gray color is having slightly less SGHC value when compared to other colors. So just to give a brief about our other features apart from heat reduction. So our fabrics comes with fire classification. It is flame retardant, and it also has bacterial and fungal resistance, environmental certifications, and 100% lead free. And we give a 10-year warranty, exterior warranty for all our Suntex range of fabrics. And we have separate fabrics for the interior application. For interior application, we give 10 years warranty. And as for Suntex exterior application, we give a 10-year warranty. So both are with 10 years warranty. And the composition is, the fabric is 31% polyester and 69% vinyl is coated. The yarn is basically polyester and coated by a vinyl. And these are all the other parameters, like how much UV is blocked by this fabric. And approximately 25% is the openness factor, the visibility of the fabric. So it can withstand up to 65 kilometers per hour wind. So this is a video, just to animated video, just to show the how we measure a balcony and how we take the measurements and do the installation of the exterior blind. So this shows about the 16 feet wide balcony. So our screens exterior fabrics are about maximum width of 8 feet. So we are bifurcating the balcony with 2 screens, 8 feet and 8 feet. So this shows how the brackets are fixed on the ceiling of the balconies. And this is a manual blind, so there is a clutch. And the fabric is mounted on the top tube and it is installed to the clutch. So we can mount it on the ceiling as well as on the wall. So vertical and horizontal mount is possible. And we also have a SS wire guide mechanism, which will prevent the screens from pulling up due to the winds. So this is how it is locked on the top and bottom. So according to the size of the balcony, we can add 1 or 2 screens. So the maximum width we can go up to is 8 feet. So just to give you an understanding of what we do in Indian market, Pfeiffer does both interior and exterior blinds in the market. So interior blinds, we have about 420 colors of different openness, starting from 1%, 3%, 5%, and it goes up to 14 and 25% openness. So normally, as per Indian temperature conditions, we always recommend 3% and 5%, and even the architects recommend that. So when we talk about EMSyS, we can say we are not even a fraction of 1% in the Indian market. So that's where we are trying to capture more number of market. So we see a huge scope of growth in the Indian market, as there are many high-rise buildings coming up with the balconies, and they were unable to control the heat, and there are a lot of issues. So currently we see a steep growth, as many people now look for exterior blinds in the Indian market. So we give 2 solutions right now. We give a separate product called balcony screens, which will be fixed on the balconies to prevent the heat entering into the living room. And we also have a separate product for exterior applications with the zip screen and motorized screens. So that can be used in other exterior areas like pergola or terrace, or wherever you want to put exterior blind. So these 2 products, main agenda is to cut the heat, block the UV radiation, and of course gives a daytime privacy, and rain and other dust resistance are possible. And our fabrics are all exterior grade fabric, heavy duty fabrics. So challenges, what we are facing in the external shading market in India is, as everyone said, it's a very price conscious market, and that's the first point. And the second point is a lack of awareness by the customer. So the customers are not aware that these many options and these many exterior grade products are available, exterior fabrics are available. That is one of the main challenge we face when we go to a customer. Because for them, when they know the product, it's easier for us to convince them. But there are many occasions where the customer is totally unaware, and they always go with some curtain or any other fabrics just to cover their balconies or windows like that. And also another challenge is there are a lot of inferior products coming from the nearby countries. So they the main agenda is to cut the heat, but these products will always cover the area, and customers sometimes feel like covering the window will give them the prevention from heat. So that is one challenge we are facing, because they compare the pricing with those products and us. And the last point is like, we can also suggest that government can organize more awareness campaign towards the need of EMSyS product, just by organizing some seminars or running some campaigns. So as per whatever the data we have seen, there is a tremendous amount of energy saving when we go for a external shading system. So that government can organize so that the customers will be aware, and they will also opt for this external shading products. So yes, thank you. I think I briefly covered all the topics.
Thank you very much, Mr. Gokul, for your presentation.
Thank you.
Finally, thank you. Thank you. Finally, I would like to invite Mr. Rishabh Bhatia with his presentation, and then we can move to the Q&A.
Hi, everyone. Good evening. Hope you can hear me, and
Yeah.
I'm just sharing the presentation. Hi. So this is thank you for the opportunity, firstly. And basically, ShadeTech, we set it up in 2013 as a partner of Alulux Germany to introduce window shutters into the market here. So it was a very new concept back then. And in 2014, we started assembly and manufacturing of these products here. Slowly, we started partnering more companies from Europe who were in this facade, and shading technology field. And we have currently got AVZ from Netherlands, Bayer from Turkey, plus 1 to other brands from Europe with us. And slowly we're trying to Indianize the product. Like cost is a big factor, so is Indianization. This is a brief product range. So we do have vertical shading sides, and then we also do horizontal shading. So we have awnings, pergolas, roofs. But today I'm focusing more on the vertical shading products, which are our window roller shutters, our fabric zip screens, and external lamella blinds or Venetian blinds. So its importance of window shades is something which is discussed throughout this whole presentation, whole webinar. And as previously mentioned, windows account for a large percentage of heat gain. So our focus when we got these products in the market was to decrease these cooling and heating costs, controlling daylight and glare, and lowering the energy consumption. So we've also done studies that we have a payback period of 5 to 8 years, depending on product and project size. Another big factor of our product is that India is a dusty country. We also help in preventing the dust from entering these places. So like I mentioned earlier, these are the 3 products we'll be showing today. So first is the Alulux window shutters. These are aluminum profiles filled with puff insulation. The profiles are coming from Germany, but we are assembling them and manufacturing them to size in India here. They provide a lot of energy saving by creating a thermal air cushion between the window and the glass. So this helps. This is the same system which a DGU glass would use, but you're adding it outside the glass, so there's no heat gain at all then. They also reduce the sound because of the aluminum puff profile by up to 30 decibels. They have a very compact and sleek design. So they can either be retrofitted, as you can see in this picture here, or we can integrate it into the facade of the building, which I'll show you later. We have a lot of options. So we have products which can take 40 kilometer wind loads going up to 300 kilometer per hour as well. And security in these areas is added benefit of these products. They can be either manual or motorized, but mostly in India, we've seen because of the large window sizes, 90% of our installations have been motorized. These are some of the looks you can get. And as you can see in the pictures on the right, that the whole system can be integrated into the walls. So in India, we have faced an issue that wall thicknesses are quite low compared to European standards, but still we've worked out solutions for that. And I'll just show you that in the next slide here. So these are two different installations to show you an inside and outside view. Now the system is very smooth, very easy to operate. And because it's aluminum, it's very easy to maintain and clean even in this weather. No matter how dusty it gets, you can easily wipe it. And we give full 5-year warranty on the motorization of it and 2-year warranty on the system here. I'll fast forward the videos a bit so you can have a better idea. This is our second product line. So these are our solid screens. These are fabric zip screens. So they are glass fiber core with a PVC coating around them. Again, they're very easy to install and operate. And they reduce the direct solar radiation entering the room by up to 95%. So this is by how the person from Pfeiffer was describing, by absorbing and reflecting the solar radiation. So we have models which have TS factor as low as 1%. And again, they give you privacy from outside, plus you get the visibility from inside. And you can easily control light and glare with them as well. We can do a size of up to 15 square meters in a single size, so which is either 5 by 3 meters or 3 by 5 meters. And they can take a wind load of 145 kilometers per hour. These can also be used as mosquito mesh on high-rise buildings where the wind load is very high. And now, last month onward, these are also being assembled in India. And this is again some product videos of recent installations. So again, from outside, you can see that there's no visibility inwards, but from inside, even when it's shutting, you get the view. And I'll put. So the color of the screen really matters in terms of visibility as well as the solar radiation protection. So depending on where the location is, we try to suggest the best color for that application. And as you can see, our boxes are very, very small. So even retrofitting is not a challenge. Here we had about, I think, 4 inches to install this whole system. And the guide channels on the side help to hold the fabric against heavy wind load. And these can also protect rainwater from coming into your through the windows. So this is a recent unique project we just did, where along the external corridor of a cliffside building, they needed protection against sun and heavy rain and hurricane. So these shutters can take a load of up to 300 kilometers per hour while being very compact. And each shutter is individually operated and connected to a BMS system. So depending on which side the sun is, they can operate them accordingly. So this is again an aluminum for the strength. And these are the third product we have. So this is external lamella blinds or Venetian blinds. They are very good for controlling daylight. They're very good for large glass facades where you want seamless integration. And they can reflect up to 80% of the sun's rays. You can completely control the degree of the louvers, which helps especially in commercial areas where you want the light, but you don't want the direct glare and the direct sun. Here also, we can do a size of around 14 square meters. There is an issue here when it comes to heavy monsoon and wind load, which is around 40 kilometers per hour. But these can be installed with wind sensors as well. So let's say if there is a heavy gust or heavy gale blowing, these will automatically retract, making sure there is no damage to the system or the facade. So these are some of the challenges we faced and solutions we've come up with, which we've done the last 6 years. So when we got the product of a roller shutter in the market here, the whole concept was new. People thought it's a shutter for a shop. So participating exhibitions, conferences, and webinars, which like this one, have really helped us and have helped to educate the market as well. And now seeing the steps the government is taking, this will also help us in the future. The aesthetics is also a big factor. That is why we made sure all the products are very integrated. They can be integrated with the design and the facade. And we have a lot of customization options to make sure architects can use the products without compromising on the aesthetic of the building. So cost of the product is also a big factor, which we are year to year decreasing by moving more and more of the production into India. We have seen a growth. We have doubled our growth every year in the last 6 years, actually. And to help our clients, we try to give them more solution-based products instead of a generic product, which we understand cannot fit every solution, every place. So we try to design it as per their requirements. And because of that, we have a whole range of retrofit models, as well as concealed and integrated models for all our products. We have another product category for vertical shades horizontal shades, where we do retractable awnings, we do full cassette awnings. We also do retractable roof systems and louvered roof systems for light control and outdoor areas. Thank you.
Thank you very much, Mr. Bhatia. With this, we conclude the presentations for today's webinar, and we are now open for question and answers session. So I welcome you all to give in any comments or questions that you would have. So if you look in the chat section, so Mr. Rizwan Ahmad, he has a question. That the flat is at top floor in Delhi, which adds a lot of heat gain through external wall and roof and windows. And what steps should I take to reduce the heat gain? Prashant, would you like to take this question?
Yeah, I think some of the points I have already written in the chat, because it is an existing building. So what is easily doable, that is what I thought to share. So basically, you would like to reduce the heat which is coming from the building envelope. So first thing is like EMSyS, which we are talking throughout this webinar. If we are able to restrict the amount of solar heat coming from outside to inside, that would have the maximum impact. So some kind of external shading that can be done, that will help the most. Second thing, it is a top floor. A lot of heat will come from the roof. So there are two ways to reduce gain from a roof. One is like if you are able to reflect the radiation, or you can put some kind of insulation. So putting insulation might be difficult and it will require a lot of cost also, but having a kind of reflective roof is still doable. So that could be done. And the third thing is, if anything can be done to have better reflectivity of walls as well, then it will help. So these are the, I would say, 3 key suggestions would be from our side.
Another question coming up, again, I think it is to you, Prashant. Which company external shading product was used in the research by Prashant?
Yeah, so this was Suntex.
Then there's another question, how to clean the EMSyS in high-rise buildings from outside?
I think this question should be better answered by by Mr. Rishabh or
Mr. Berkeley. Yeah.
So in high rises, so where there's balcony, there's not an issue of cleaning, because if you can access the balcony, you can easily clean the products. In other situations, when they're high rises, we've seen that normally most of the buildings do offer window cleaning services on the outside when there's no balcony. So at the same time, these products also have to be cleaned.
Okay, thank you. I think another question is for Mr. Gokul. What would be the FR rating for the system that was shown by you in the presentation? Mr. Gokul, can you hear us? There's another question. Why daylight increases by external shading? Any equation that you have developed for the same? I think Prashant, you can take this question.
Yeah, so I think let me just show the product image once again. I'm sharing my screen. I hope that is visible.
Yeah.
So what you see that this kind of external shading which we have used. So these are not completely opaque. So they have small holes. So a lot of diffuse light can come inside. Whereas if you have a kind of a thick curtain, so it will kind of restrict more light like this kind of curtain as compared to something what you see in this picture. If you have small holes, it will allow a good amount of daylight, diffuse daylight to come inside the space. So the numbers what were shown in the presentation, those are measured numbers. So nothing like equation or nothing deriving from an equation. Those are the measured numbers, and those were spot measurement. And that was not a kind of long-term study. It was done only for specific times. But it gives a fair idea. Definitely there is a much better daylight inside with EMSyS as compared to internal curtains, thick internal curtains.
Okay, thank you. I think then we have from Mr. Manoj, it's a comment addressed to the manufacturers saying that we'll be conducting an exhibition for energy efficient products in the coming months. And will the companies be interested in arranging one-on-one discussions with the industry representatives? So, Mr. Rishabh, would you like to comment on it?
Yes, we would be interested in something like that. It will help us get to reach more people and clients.
Okay. That's again then a question by Praveen saying, is there any change in the efficiency by changing the gap between window glass and the EMSyS? Prashant or someone from the group, would you like to do?
So I think if you have the gap within a kind of 1 inch or so that will not have a lot of impact. But if you increase the gap large, then it might have more impact. So so basically the main purpose of external shading is to reduce the solar gains. So the conduction gains all will not change much with respect to the kind of distance between the EMSyS and the glass. And the solar radiation, like the reduction in solar gains, that will be that will not have much impact even if the distance between glass and the window varies a little bit.
Okay, thank you, Prashant. Then I think there were some people asking about the directory for the materials of the...
I just want to add something, Chima, sorry.
Sure. Yeah,
I think regarding the gap, there is not only the thickness of the gap, but the openings, the possibility for air to travel. Because if the gap is completely closed on the sides, then you will have an increase of the temperature of the air gap. And that will increase also, especially with single glass, it will increase the SHGC value because you will have a hot air trapped in between. So it's relatively important to have some kind of clearance on the side or on top, bottom, so that air can circulate also. But of course, it depends also of the kind of control. If you are in a fully AC building or if you are in a naturally ventilated, it will also change a little bit. But basically, the idea is that you should let some air pass between the shading and the glass.
Okay, thank you. Okay, I was just saying that regarding some queries that had come for the BMTI portal, I think Ms. Akanksha Krishnan has already shared the links which are available where we can find these building material directly by BE. So we can take one more question before closing the webinar.
No, there is somebody, Manoj 5 India, Manoj raising his hand over there. Oh,
Okay. Yeah, I think this we have already posted it to the
okay.
to the industry representatives, and they say that we would be interested in something like that. Okay. So I think as we are a bit over our time, we can conclude the webinar here. Of course, we are open to all the feedbacks, comments, and queries on the external shading via email, and we look forward to receiving all your comments. And I would like to thank all the participants, the speakers, and the audience for the engaging and interesting discussion on external shading. We will be sharing the recording of the webinar and look forward to your comments and feedbacks on the same. Thank you and have a good evening.
Thank you. Bye. Bye, everybody.
Bye.
Thank you. Bye-bye.